Hello and welcome to Lab 3. We're talking the moon, eclipses, and tides, and today we're going to be talking about eclipses. So here is this really fancy schmancy picture I found online. It's a little bit complicated and it's kind of like an engineering drawing, and so I wanted to sort of walk you through this a little bit. So the key for something like this, just like a map, you need to find something that you kind of recognize. So that's sort of like the scientific way to approach a drawing like this, or even a graph or something like that. So here we have a big circle and we have a small circle, and this one's labeled Earth's obliquity, right? Here's Earth's axis, north and south. We can sort of recognize that. Earth's equatorial plane. So if you notice, I did the overall scan of what it is, and then I looked at the smaller things and started looking at the labels. Okay, so here's Earth's axis. So we spin about this axis, and then what's going on? And then here we have, here's the axis, and we have equatorial plane. So this is basically where the equator is. And then here along this line is the ecliptic plane. So this is the line, if you were to continue along this line, you would see the sun out here, because the path the sun takes through the sky is called the ecliptic. Okay, so this is the Earth relative to the sun, but then this is the moon relative to Earth, okay? So the orbital plane of the moon is oriented 5 degrees here, actually, from the ecliptic, sorry. Anyway, so we have a situation where the moon is not sort of lined up with everything, right? So if I'm going to switch to a pen here. If this was not inclined, then the equator, of course, would be along the ecliptic plane, right? And then if this was not inclined, we would have a situation where here's the Earth, here's the moon, and here's the sun. And we would always have an eclipse in this scenario every 2 weeks. So we'd have a solar eclipse during the new moon, and we have a lunar eclipse during the full moon. So basically what this means is the shadow of the Earth would be projected, no, the shadow of the moon would be projected on the Earth. In this case, I need a different color. I'm making a mess, sorry. And then the shadow of the Earth would cover the moon in this situation. So here we would have a solar eclipse and a lunar eclipse, if we were aligned in such a way as we had no tilt to our orbit and the moon was also not tilted. So because we have this crazy situation, I'm going to remove all this for right now. Because we have this crazy situation where we are tilted, and there is an inclination to the lunar orbit, we only have eclipses maybe 2 times a year, 4 times a year, something like that. So if you have a solar eclipse, you will then also have an accompanying lunar eclipse like 2 weeks later. It's kind of a cool thing. We had an eclipse earlier. We had that eclipse in 2017, and we also have an eclipse in 2024. Actually, there's one in 2023 as well. Anyway, so it's pretty exciting. So that is the situation. If we had specific scenarios, then we would have eclipses every 2 weeks and it wouldn't be a big deal. But because we have this inclination here, and because we have this inclination here, we don't always have the proper setup. Okay, so I'm just showing you this slide here. Originally, when I first saw this image, I thought it was actually really a picture, but I think somebody generated this photo and tried to put the Earth and the moon to scale. So this is kind of interesting. The sun is a kind of an average sun, but it's huge compared to the Earth. So this is a sunspot here. This is sunspot over here. I think this is also a little sunspot right there. But they have, to scale, put the Earth and the moon and the proper distance between the Earth and the moon. And so it seems like the moon is really close, but that is how far away it is. It's really kind of cool. So in order to get these all lined up, like I said in the last photo, in order to have an eclipse, you have to have, of course, the sun, and then the moon has to be between, obviously not to scale, between the sun and the earth, and its shadow has to fall on the earth. And then for a lunar eclipse, the sun or the moon has to be back there, and the shadow of the earth has to fall on the moon. Okay, so here's sort of a picture of the 3 different types of solar eclipses that we have. So here we have the Earth, we have the sun, and we have the moon. We have the moon here in this position, and if you notice, it's farther out, and it's also a little bit farther out here. So the moon does not always orbit at the same location. It orbits in an ellipse, and so sometimes it's closer to the Earth than it is other times. If it's close to the Earth and there's an eclipse, we have a total eclipse where the sun is totally behind the moon. That's what happened in 2017. That's what will happen in 2024. If when the eclipse occurs, the moon happens to be kind of farther out in its orbit, we will have this thing called an annular eclipse, and that's where the moon only covers up it only partially covers up the sun, because the weird thing is the angular, remember the angular size that we measure, the weird thing is they're the same generally. How weird is that, that our little moon and the sun line up, they're the same angular size in the sky. Even though this is huge, we're able to cover it with this tiny moon, right? Because just that's the way it works out. Anyway, but sometimes it doesn't work out as well because the moon happens to be a little bit farther, and so its angular size, the projection that we see on the sky, is smaller, and so it doesn't cover up all of the sun. And then finally, there are situations where the moon only partially covers the sun, and it makes this kind of weird picture. You can see it actually going across. I would encourage you to maybe Google all 3 of those images, and in the essay part of this lab, give me your impression of those, because they're quite dramatic. Anyway, this actually occurred one time when I was in high school. It was really weird. The sky got really dark. It didn't get totally dark like night or anything, but it did dim significantly. So anyway, so there's solar eclipses, 3 different types. And then finally, I liked this image for a lunar eclipse. Okay, so a solar eclipse is when we are eclipsing the sun. A lunar eclipse is when the moon is in shadow. So anyway, a solar eclipse would be when the moon is over here. But a lunar eclipse, so here's the orbit of the moon. So the path of the Earth is going this way, the moon is going this way, and then we get a lunar eclipse when the moon passes in the Earth's shadow. It can partially pass in the Earth's shadow, or it can completely pass. So we have this preumbra and the umbra that we talk about sometimes, and so this just basically, the shadow is in the umbra and the preumbra is the partial shadow. So it's not as shadowed. It's still shadowed, but not as shadowed. And there's angles and everything associated with that. And so the really weird thing about the lunar eclipse, when it actually gets in this part here, you can see an eclipse going on, but when it gets in here, it gets red. It's really crazy. I would encourage you to Google pictures of lunar eclipses as well. Okay, as always, let me know if you have any questions. Oh, and one little thing, I'm going to give you a real quick sky navigation. A few people had mentioned that, they were having a little bit of trouble with sky navigation. So, I'm going to do this backwards so there's stars up in the sky. This is the horizon line. This is you standing out in a field with nothing obstructing your view. If I were to tell you, okay, so if I'm looking north here, I'm looking, that's not up. This is north, sorry. Oh. Okay, let's say that's up since I drew it up, duh. Okay, so up would be 90 degrees, right? So here you are. I want to make you a person here. Okay, so you look to the horizon line, and that is an altitude of 0. You look directly overhead, it's an altitude of 90 degrees. Okay, and so if you were to look anywhere along this path, you would give the angle. So this is about a 30-degree elevation. This is about a 60-degree elevation. This one's about a 45-degree elevation. Okay, so our altitude is measured in degrees. And if you remember in the last lab, the last little video had cheats on how you can kind of use your hand to estimate, like your pinky is a half a degree or something like that, and your fist is 5 degrees or something. Anyway, so that is altitude. It's also declination in the celestial coordinates. So we have the local system, which is Alt-Az. And then we have the standard system, which is right ascension and declination. And that one is based on, the solar, the vernal equinox. The position of the sun in vernal equinox is your 0-0 position. Okay, so when you're going around the sky, though, if this is north, and then this would be west, and this would be east. So it's like on a compass. So the compass needle points north. And then this is 90 degrees, this is 180 degrees south, this is east, and west would be 270 degrees. And so you find your way around the sky by turning first. So I start north, get my compass out, I start north, I turn to a specific location, and I'm pointed that way, and then I will look up in the sky. You could look up in the sky at 45 degrees and then spin around, but it's kind of easier to reference off the horizon line, right? So that's how you find something. So you find this is your azimuth. So you would find your azimuth first, and then you would find your altitude. So next time we do an observing thing, which I think is going to be the crescent moon coming up. Let me find the dates. Crescent moon coming up is the next one, and so when you find your location in the sky, when you navigate, that's what you will be doing. So the next one is Mercury at sunrise is on July 4th, and then July 11th and 13th is when we have the next crescent moon. Anyway, okay, if you have any questions, let me know. Thanks.